Hey guys, today we're learning about double replacement reactions. Okay, so what is a double replacement reaction? It's when two parts of an ionic compound are exchanged, making two new compounds. Okay, so we have like single replacement reactions that we've already talked about, where you have one element in one compound switch their parts. Okay, now this is two compounds that are switching parts, so it's like switching dance partners. Okay, instead of asking to join a dance, or instead of asking to dance with somebody, now it's two people who have dance partners that are switching places. All right, so to kind of give you an example of that, all right, so we have a metal and a non-metal, okay, A plus and B minus. And let me get some more colors. All right, plus another ionic compound. So this time we'll say C is the metal and D is the non-metal. Okay, so two ionic compounds that are switching their dance partners. So now A is going to be paired with D, and C is going to be paired with B. Okay, so notice that I don't have two positives together over here, or two negatives together. All right, I have a positive with a negative, positive with a negative, and that's how all of the compounds are. So remember that positives are talking about metals, negatives are talking about nonmetals. Okay, so whenever these happen, the metals are joining with a different nonmetal. Okay, or the nonmetals are joining with a different metal, but you never have two metals together. You never have two nonmetals together. All right. So again, double replacement reaction is when two compounds switch their partners. Okay, making two completely new compounds. There are two types. Okay, we have acid base. And we have precipitation. All right, so again, acid base and precipitation. Trying to make sure you got time to write it down and switch. Acid-base reactions always start with a hydrogen ion, or H plus. That's what a hydrogen ion looks like. Okay, so same thing, name, symbol. All right, so examples of acids would be like hydrochloric acid or chlorous acid, HClO2. Okay, we just got done naming these with nomenclature, so you should be pretty familiar with what is an acid. All right. So that's what the acids will start with. Then it's going to be joining with something called a base. And a base is something that always ends with a hydroxide ion or OH minus. That's what the hydroxide ion is. Okay, so when you see a compound with OH at the end, that is a base. All right, so examples of that would be sodium hydroxide, or you could have magnesium hydroxide. Okay, magnesium has a charge of 2, that's why there's a 2 outside of this. But anytime you see the OH together at the end, you're dealing with the base. Okay, so acid-base reactions are going to have this as, or an acid as its first compound and a base as the second compound. And when the acid and base are mixed together, you will always get salt, salt and water. Okay, salt means an ionic compound, not the table salt that you use. Sometimes it's the table salt that you use, but just in chemistry, when we talk about salt, we're meaning a metal mixed with a non-metal, or metal combined with a non-metal. Okay, so if I took a really strong acid like hydrochloric acid and a really strong base like sodium hydroxide, which happens to be this example, so I don't get too far ahead. Okay, so super strong acid, like this is like stomach acid quality, super strong base, like oven cleaner kind of stuff, right? When you mix them together, you get salt, like this is table salt that you eat, and water. Okay, so it neutralizes the compound. Now, we're later on in this spring, like after spring break, we're going to get into a lot more detail on acid base, like what they do, what I was just talking about with the neutralization. But for now, you just need to see the equation and be able to recognize it. So anytime you have something that starts with H, ends with OH, okay, and has water and a salt, okay, mainly it's if you see water, okay, H, OH, and water, and then you're dealing with an acid-base compound. Okay, so like here we have H, OH, water. This is acid base. Okay, that's how you're going to recognize these. If you want to write that down, I suggest doing that, or circle it. H and OH makes H2O, acid base. Okay, so next we have a precipitation reaction. This refers to two solutions of ionic compounds being poured together and having a solid form in the new solution. Okay, so I know that sounds weird. I'm gonna link up a YouTube video to kind of show you what this is talking about. But again, it's like I have two clear liquids in my hand, and whenever I pour them into the same container, all of a sudden, like a different color appears or the solution gets cloudy. Okay, the clouds that form are solid compounds, and if I were to just leave the container there with the mixed liquids, the cloudy contents would form like sand on the bottom, kind of thing. All right, and then you'd have the liquid up top. All right, that's precipitation. Precipitation means a solid formed. All right. So again, let's watch this video so you can see it in action. What you're seeing in this video is potassium iodide and lead nitrate, okay, which are both aqueous. Aqueous means that potassium iodide is dissolved in water. Okay, and I don't think I have this on your notes, so you might want to add the aqueous and that the AQ means dissolved in water. So you have potassium iodide dissolved in water, lead nitrate dissolved in water. When you mix them in the same container, that's when the yellow pops out. You still have the clear liquid, but you also have yellow. Okay, the clear liquid is potassium nitrate, but the yellow is the lead iodide forming a solid in that liquid. Because whenever the lead and the iodine touch each other, boom, solid form. There's a force of attraction between them. Okay, so this solid is your precipitate. If I can spell it. Precipitant. I don't feel like I spelled that right. I'll double check on that. Okay. Yeah, so that's what makes this a precipitant reaction. Okay, so let's look at some problems and we'll practice balancing them out as well. Okay, so first, what kind of reaction is this? I have an ionic compound, so two ionic compounds. I don't see H, I don't see OH. Right, so with two ionic compounds, that is going to be precipitant or precipitation. I keep feeling like I'm spelling stuff wrong. All right. To balance it out, we're going to list the elements that we have. So I'm just going to start with the left. So we have silver. I have NO3 right here. I also have NO3 on this side of the equation. So I'm going to treat it like it's one element. And I'm going to put it in parentheses so I don't get that 3 mixed up. Okay, because I have one NO3 here. I have two NO3s here. All right, and then we have calcium and chlorine. So now I'm going to count. I have one silver, I have one nitrate, one calcium, and two chlorines. I have one silver, one chlorine, one calcium, and two nitrates. Okay, so as I'm looking at this, I see that first my nitrates aren't balanced. I have two here, but I only have one here. So if I put a 2 in front of that, I now have two nitrates. And that also gives me two silvers. So I'm going to go to my silver and I'm going to mark that with a 2. Okay, when I scroll down, I see calcium here. And I see my calcium's good, but my chlorine's not. I have two chlorine on the left side. I need two chlorine on the right. So if I put two chlorine here, or 2 here, that gives me 2 chlorine, and that also changes my silver to 2, which just so happens to balance it out. So I have 2 silver on each side, 2 nitrates, 1 calcium, 2 chlorines. So this is my balanced equation. You can either leave these blank right here, or you could say 2, 1, 2, 1. Okay. If I did the balancing fast, I apologize. If you're still struggling with balancing, please make sure you're talking to your teacher. Don't just sit there. Okay, talk to your teacher. Also encourage you to go to YouTube, do balancing chemical equations. You're going to see some really good tutorials on there. There's a lot of different ways to balance problems. Okay, like even the teachers here, we all have our own ways of balancing problems. Not one of them is not more correct than the other. Okay, as long as you're getting the right answers, then you're doing it correctly. So again, if the way that I'm teaching you is not working for you, feel free to look up YouTube questions or ask me or whoever your teacher is to teach it to you in a different way. Okay, this if you're not a numbers person, this could be a little tricky. So let us help you out. Okay, next, what kind of equation do we have? Right, I see H, I see OH, and I see H2O. All right, so this is acid base. Okay, so when I list out what I have, we have hydrogen, we have bromine, we have potassium, okay, and we have OH here. Another way that you can write water when you see this is HOH. This helps me when I'm balancing them out. Okay, so if you see water and you have hydroxide on one side of the equation, rewrite the water as HOH. So that way you can treat hydroxide like an ion or an element. Okay, so here I have one hydrogen. Here, now I can act like this hydrogen's by itself, so one hydrogen, one bromine, one potassium, one potassium, one hydroxide, and only one OH, this problem's already balanced. Okay, so I can leave these blank, or I could fill these in with ones. Again, fine either way. All right, so next, I see H, I see OH, and I see water. So this must be acid base. All right, I'm going to rewrite my water as HOH. And now I'm going to list my elements. So we have hydrogen, we have SO4 here, and I have SO4 on the product side, so I can write SO4 as an element. All right, then we have calcium, and then OH and OH. All right, so we have 2 hydrogen, 1 sulfate, 1 calcium, 2 hydroxides. On the product side, we have 1 calcium, 1 sulfate, 1 water, and 1 hydroxide. Okay, so my hydrogens are not balanced. I have 2 over here, but only 1 by itself over here. So if I put a 2 in this coefficient, that gives me 2 waters, and it also gives me 2 hydroxides. And now when I look at this, I have 2, 1, 1, 2 on both sides of the equation. So that's all I needed to do to balance this one. So again, I'm going to put 1s here, but you can also leave them blank. Fine either way. All right, we got 2 more. Oh, 3 more. Just kidding. Okay. Yeah, if you're feeling pretty good on this, then try to balance. You can pause the video, identify the type of reaction, go ahead and balance them out, and then just kind of fast forward the video to double check your answers. If you're still having a hard time, I'll keep walking through this. Okay. So here I have an ionic compound. I have OH here, but I don't have water over here. So this is 2 ionic compounds. So this is precipitant. Okay. And with the aqueous and a solid, this is my actual precipitant. But that's not what we need to know right now. Okay, now we're going to try balancing it out. So we have magnesium, chlorine, sodium, and we have OH here, and we have OH here, so I can treat OH like one element. Okay, 1 magnesium, 2 chlorine, 1 sodium, 1 hydroxide, 1 sodium, 1 chlorine, 1 magnesium, and 2 hydroxide. Okay, so if I try to balance out my chlorines first, because I have 2 chlorines on the reactant side, then I'm going to put a 2 in front of the NaCl, so that way I have 2 chlorines. Now, when I double my chlorines, when I double my, there we go, 2 chlorines. When I double my chlorines, I also have 2 sodiums. I apologize for jumping ahead right there. Okay, so now I need to balance my sodium on the reactant side. So I'll put a 2 coefficient in front of sodium, which also gives me 2 hydroxides, which happens to balance out my hydroxide. So at this point, I now have, I forgot to write a 2 right here. At this point, I now have a balanced equation. Okay, 1, 1, 2, 2, 2, 2, 2, 2, good to go. Okay, again, I prefer filling in my blanks with 1, so I know I didn't skip anything. You don't have to do that. Okay, so for the next one, we have H, OH, H2O. So this is acid base, which means I'm going to rewrite water as HOH. Okay, we have hydrogen, chlorine, calcium, hydroxide, 1 hydrogen, 1 fluorine, 1 calcium, 2 hydroxide, 1 calcium, 2 fluorine, 1 water, 1 hydroxide. Let me put that in parentheses so we don't get confused. Okay, so my fluorine starts off as the first one unbalanced. I have 2 fluorine on the right side, so I need to make it 2 fluorine on the left, which also changes my hydrogen to 2. Okay, so now my hydrogen's unbalanced, so when I look to the right side, I need to put a 2 here. So that gives me 2 hydrogens, and it also doubles my hydroxide because they're in the same compound. So I'm going to put a 2 here. When I look at calcium, I'm still balanced with 1 calcium on each side. And again, when I look, everything's balanced now. 2s, 2s, 1s, 2s. Okay. All right, here, an ionic compound, and then we have 2 ionic compounds on the other side, so this must be a precipitant. Okay, but notice how there's nothing solid here. Not all precipitation reactions have a precipitant, okay? So this should have said precipitation, but you know what I mean, okay? Yeah, not all of them form a solid, okay? So in this case, it'd be no reaction happened, but we're gonna go ahead and balance it out anyways. Okay, so CO is cobalt. If you have a little o like this, and it's talking about the element cobalt, and then Cl is chlorine, sodium, and we have SO4 right here, and we have SO4 right here, so I can put SO4 down. All right, we have 1 cobalt, 2 chlorine, 2 sodium, and 1 sulfate, 1 sodium, 1 chlorine, 1 cobalt, 1 sulfate. Okay. So on the left side of the equation, I have 2 chlorines and 2 sodiums. So if I pop a 2 right here, that gives me 2 sodiums on the product side and 2 chlorines. And it balances out my equation. So that's the only coefficient that I need. So I can mark everything else as 1. Okay, I know I went over the balancing kind of fast with this. You've been working on it. And so, yeah, so that's why I didn't go as slow. But if you need me to slow it down, either slow the video down or ask me personally to explain to you slow down, okay? Again, it's going to do nothing but help you. If you can understand balancing, it's going to really help you with the next couple of sections, okay? Again, watch YouTube videos if you need to. Have confidence in yourself, though. You're strong and you're smart, okay? You're going to get this. It might not click today, but maybe it'll click tomorrow, okay? Or if it has already clicked, then pat yourself on the back. You're doing a great job, okay? I appreciate you guys for listening, all right? There are a few knowledge check questions if you guys want to go ahead and start working on those, all right? Keep up the good work. Stay strong.